Okay, so as a first flavor of injections, we're going to be looking at command injections. With command injections, usually the target is the web server that we want to gain remote code execution at. So in the introduction, I had this very simple example where we just chose a username with a semicolon in order to call new commands. First, I want to talk about what could we actually do with that. I mean, okay, we can delete files off the file system via the shell, but is that so useful? Okay, so gonna show some example payloads of things that we could do. Well, for example, we could leak files. Cut just outputs a file to std out, and this redirects std out to a file, and we use this magic file that's available in bash. Bash is a shell that's commonly used that sends the output to this IP address at this port. And if we control this IP address, obviously we can read the contents of the file. Well, maybe in the same directory there are PHP files that are interesting. Why would they be interesting? Well, maybe they contain, for example, database passwords that we can steal. For that, we could just redirect the output of this file to a file in the web root and then access this file via the web server. Or we could do something called HTTP callback. We could use curl, that's the command line utility you know by now, and then make an HTTP request to a server we control, and on this server, in this HTTP request, we set, for example, a get parameter to the output of a file, of a command. So $ brackets means everything within this will be executed as a command, and then the output of the command will be appended to this command here. So this way we could execute ls and see the output in our web server's log. Well, we could of course also persist our remote code execution, that is, find a way to make it easier for us to work interactively with the shell, for example. We could do that by creating a web shell. This PHP code here. This PHP code here takes the get parameter c and then just executes it on a command line. That's what these backticks do in PHP. And then we save that as a file called .test.php. The leading dot leads to ls not showing it. Usually it's a hidden file, unless you use ls with the -a or capitalized A option. Another way would be to invoke netcat, it's the nc command, nc -e, -l -p, and then a port means as soon as somebody connects to this port, we execute the program bin shell, and then we can interact with bin shell. So if we have executed this, we would just need to connect to the server on this port, and then we have a direct shell access with output as well. So remote code execution, command injections leads to remote code execution, just means we can do absolutely everything on the server. We control the server because we can execute arbitrary commands, and of course the shell is Turing complete, so we can do whatever we want. What criminals would usually do on a server is either they would steal user data and sell it, or they would install, for example, a key stealer. Maybe you use SSH forwarding or that kind of stuff, so they can steal access or gain access to other systems as well. Or what happens often is they would install a crypto miner. So, for example, your server mines bitcoins for them. So that was a very simple example here. You could see how that could go wrong, but there are more subtle examples to command injections. So here's another example. It's a Python script. Now imagine there's a shared server. You use the server with other people, but you're not root. You're just a normal user, but you want to escalate your privileges. So you become root. So imagine there's a cron job on the system that runs as root, as often the case. And within this cron job, there's a Python program used, and it does something like this. It does os.system, which essentially does the same as exec. Details are a little bit different, but essentially this string here will be executed on the command line. So then it changes the directory into a user folder, and then it creates a backup with the tar utility, which is commonly used. Tar create zipped file just creates a file called backup.tgz, which is a compressed archive, Linux archive type. Then it uses a asterisk. This asterisk on the command line is a wildcard. So this will be replaced by all the file names in the directory. So now let's assume within this user folder we can create files with arbitrary file names. Now maybe think about if this could lead to code execution. If we can just create files. Well, as it turns out, yes. We can create file names. Let's just create two files. One with the file name, one with the file name --checkpoint equals 1. And one with the file name --checkpoint exec something. Well, the tar program that's being used on the command line here has a nice feature that is, as soon as it reaches a checkpoint, so in this case after 1% is done, it can execute a command. So in this case, checkpoint action, that will be this will be executed every time 1 more percent is done, let's say. And what it does is what we've done earlier. It creates a netcat process that listens on a port and supplies a shell. So why is this called? Well, as I've said, this asterisk, this is a shell wildcard. So the shell will replace this asterisk with all file names in the current directory. And since we have created these file names, they will be appended here by the shell, and the tar program has no chance of knowing if these are meant as command line parameters or as file names. So the tar program just receives this as an argument and this as an argument, and then after the checkpoint it will execute our command. And since this is run in a root context, if we connect to the port, we have a root shell and we can do whatever we want on the system. That this is not just a theoretic attack, that command injections are a thing that happen in real life. We'll see that in the next video, which will go over some examples of real-world systems.